Hello friends, this is Dr. Sudhansh Sharma from School of Computers and Information Sciences. Today I welcome you all to this session of MCS 227, that is Cloud Computing and IoT. And in this session we will be discussing about resource virtualization. In this session the objectives are actually to discuss about what is virtualization and what is resource virtualization, and among the resource virtualization we will be discussing about server level virtualization and many more different types of virtualization, specifically the machine virtualization. Now in the last session we had already discussed about the cloud architecture, wherein it is comprised of actually 4 layers. One is the layer which is accessible to the client. Thereafter we are having the internet layer, because the client is accessing the resource pool with the help of the high speed internet. And in the resource pool we are having the virtualized configuration of different services, and they are working on the physical hardware. So we also learned about different services, that is SaaS, software as a service, platform as a service, and infrastructure as a services. So we had also learned about the SPI model, that is software, platform and infrastructure as a service model, wherein we learned about that which type of services, which type of layers are accessible to the client, and which layers are actually provided by the service provider. After that we also learned about that there are different type of layers. There is a virtualization layer, infrastructure layer and physical layer for IaaS as a service, that is infrastructure as a services, which is generally used by infrastructure architects. So far as the software developers are concerned, they are actually concerned with the platform as a service, and the end user is typically concerned with the software as a service. So please show the slides. Now these are the objectives, and these are the things, that is the cloud architecture. We learned in the last session that there is a client access layer, there is an internet connectivity layer, cloud service management layer, wherein different services SaaS, PaaS and IaaS are available, and there is a physical resource layer. Thereafter we also learned about that SPI model is there, and we also understood that software as services is accessible, is generally utilized by the cloud user, and platform as services is utilized by software developers, wherein the infrastructure architects are actually using the infrastructure as a service. And in the SPI model we learned that in infrastructure as a service the user is able to manage the application, data, middleware and the guest operating system, whereas the service provider, that is a manager, a provider manager, is actually regulating and taking control of virtualization, storage, servers and network. Thereafter in platform as a service we learned that user manages the application and data, however the provider manages the middleware or guest operating system, virtualization, storage, servers and network. And being on the software as a service, application, data, middleware, guest operating system, virtualization, storage, servers and networks all are under the control of the provider. So we also learned about the layers and anatomy in the last session, and we identified that software as a service, wherein the web applications are generally explored. There is this is done at the application layer, and general examples are Google Suite and Microsoft Office 365. And platform as a service, the software platform and the data management tools are available at this layer, that is the platform layer, wherein the Google application engine and Cloud Foundry and Salesforce, Heroku are the common examples which are working as platform as a service. So far as infrastructure as a service is concerned, it is comprised of 3 layers, that is the infrastructure layer, virtualization layer and physical hardware layer. At the virtualization layer, the virtual computing environment, virtual storage environment, virtual network environment is available. Therein the examples are Google Cloud Engine, Compute Engine, Rackspace as Microsoft Azure, Amazon Web Services. Apart from this, hypervisors are available at virtualization layer, and the most common examples are Zen and VMware. The physical hardware layer relates to the actual storage of the actual hardware related to the storage and the networking and the computational power of the system, and there lies the example of the data centers. Now in the today's session we are going to discuss about the concept of the virtualization. Actually the virtualization is abstraction of the resources which are available into the computer. The resources might be your storage resources, your network resources, your processors. So virtualization is actually the abstraction, the replication of the hardware resources, and it is actually very helpful in providing multiple instances of the same environment to the multiple users. So we abstract the hardware, that is the processor part, storage part, memory part, and make it available to the multiple users. Now, in order to regulate this, we need to have an emulator, that is the software which customizes, which provides the abstraction of that hardware part, and that hardware, this emulator is known as hypervisor. Hypervisor is actually the software which controls, this is a virtual machine manager or virtual machine monitor, which actually regulates the working of the virtual machines, because when multiple virtual machines are available on virtual machines, the different operating systems are running, and on different operating systems different applications are running. So one has to regulate these virtual machines so that there should not be any conflict in between the execution, because all virtual machines are sharing the same host machine. So multiple guest systems are working on the single host system. So single host system is working on the physical resources which are available onto the data centers. That means the processors are there, storage devices are there, networks are there. So because multiple virtual machines are sharing the same physical resources, it is to be ensured that there should not be any conflict. So in order to avoid that conflict, some of the features are to be ensured. Likewise, the virtual machines should be secure. They should be working in an isolated environment. They should be sharing the resources, and when they are sharing the resources, there should not be any conflict, because if there is any conflict, then obviously there might be a situation of the starvation and the deadlock environment. So all these things are being controlled by the hypervisor. So virtualization is actually the abstraction, and the most preferable example of virtualization is hardware virtualization. Please show the slides. So actually in the cloud environment, the maximum customization and control over the hardware resources is enabled, and this relates to the utilization of the hardware resources to the maximum capacity. So hardware virtualization plays an important role in provisioning of the IaaS, that is interface infrastructure as a service. Now there are different types of virtualization, because as it is already discussed, that we are going to abstract the server, we are going to abstract the operating system, we are going to abstract the network, storage. So there are different type of virtualization, that is server level virtualization. In this session we will be discussing about the server level virtualization at the end, and later on we will be discussing about the different type of virtualization. However, some of the common virtualization over here are server level virtualization, hypervisor based virtualization, operating system level virtualization, network virtualization, storage virtualization, and desktop virtualization. Actually, in virtualization, we are supposed to ensure that the environment should be secure and isolated. Whenever the multiple operating systems are working on the virtual machines, and there should not be any conflict. So we are supposed to ensure that the data security should be there, and the devices should work in the isolation. One should not intervene into the working of the other. And even if say one of the machine is compromised, or if something goes wrong with that virtual machine, then the performance of other virtual machine should not be hampered. So in order to ensure this, we are supposed to maintain some of the features related to the virtualization we will be discussing in this session. So far as virtualization is concerned, there are two approaches. There was a traditional approach to the virtualization, and now we are having the virtual machines approach. So far as the traditional virtualization technique is concerned, it is quite slow, because directly the operating system is working on the hardware, and the applications are accessing the hardware with the help of the operating system. But in the case of the virtual environment, that is the latest concept, the virtualization layer is actually working in between the multiple operating systems. The virtualization layer is actually providing the abstraction of the physical resources to the multiple virtual machines, and to the multiple operating systems, and over those operating systems multiple applications are running. So while looking on the slides, you might compare that in the traditional approach, in the traditional architecture, we are having a physical hardware over which operating system is running and the applications are running. But in the virtual architecture, that is the current approach, the physical hardware is there is a layer of virtualization layer which is working on the physical hardware, and the virtualization layer we are having multiple operating systems, and on the multiple operating system multiple applications are running. So the current virtualization procedure is quite fast, it is flexible, at the same time it is optimizing the resources to the higher end, wherein the traditional architecture is quite slow in comparison to the present approach. So actually into the virtualization architecture, we learned that is multiple guest virtual machines are working on a single host machine. So the single host machine is supposed to manage these multiple virtual machines, so that there should not be any conflict, and this is taken care by the VMM, that is virtual machine manager or virtual machine monitor. Now, this virtual machine monitor plays an important role by managing the virtual machine efficiently and providing enough security. And operations of the different virtual machines are observed by the VMM and filtered accordingly so that no unfavorable activity is permitted. So sometimes it becomes very important to hide some of the sensitive information or important data of the host from other guest application running on the same machine, because they are sharing the same physical resources. As I already said, that virtualization is abstraction of the physical resources. So it appears that each and every virtual machine, each and every person, or each and every application is allocated with the separate hardware resources, but in actual they are sharing the same hardware. The abstract part is provided to each virtual machine so that they work all together. So many a times the data security is very much required. So security is an important part, and it is a cloud security is an important part of research also. So, so far as the virtual environment is concerned, we are supposed to understand that there are three layers. There is a virtualization layer, which works in between the two layers, that is the guest layer and the host layer. So the host layer is actually the physical layer. Virtualization layer provides the abstraction layer, wherein the virtual hardware, virtual storage, virtual networking are emulated. That is, emulation is a software which provides the abstraction of the real resources, that is the real physical hardware, real physical storage, real physical networking. They are emulated into the virtual hardware, virtual storage and virtual networking at the virtualization layer, and their image is worked at the guest layer. So virtualization environment is actually a software program which provides the virtualization technology, that is the abstraction of the resources, and the capability of this software is actually to imitate a real computing environment and facilitate the utilization of the resources in an efficient way. So overall we learned that there are three layers. There is a host layer, there is a virtualization layer, and there is a guest layer. And the host layer denotes the physical hardware devices on which the guest is maintained. Thereafter, the virtualization layer serves as an intermediary, crafting a virtual setting mirroring a real computer environment for running the guest virtual applications. Actually, it provides the abstraction of the resources which are physically available. That is, the virtualization layer actually works on the host layer. Above the virtualization layer, we are having the guest layer, and the guest layer always communicates through the virtualization layer to the hardware, and it may denote a virtual machine or any other virtual application. So there are different features. Apart from security, we are having the multiple features, likewise sharing, aggregation, isolation, emulation. These are some of the features which are primarily required for the virtualization. Now, as I already said, that security is of prime concern because multiple guest machines are working on to the single host machine, and the host machine is actually replicating the physical hardware. So the physical storage, physical processing power, physical networking, all are being abstracted at the virtualization layer. So because they are sharing the same storage device, replica of the same storage device, so if security concerns are not handled properly, then there might be a issue of the data leakage. So in case of data leakage, it is a security issue. So one has to ensure that the cloud applications should properly work in an isolated environment and a secure environment wherein the sharing of the resources is done in a proper manner. Now, because there are multiple applications are sharing the number of resources, and if the situation of deadlock may occur because of the resource sharing, then the entire system may hang. So it is the responsibility of the virtual machine manager, that is your hypervisor, which is just an emulation or an emulated software to abstract the physical resources. It is the responsibility of this virtual machine monitor to maintain the sharing of the resources and security also. Apart from this, aggregation. Now, each resource, each application is requiring processing power, is requiring storage power, is requiring networking power. So all these things are to be aggregated. Apart from this, they are to be shared. So the situation is not easy. So virtual machine manager is actually aggregating all the resources, making it available to the multiple applications through multiple virtual machines. So aggregation is again an important issue. So security, sharing, aggregation, and the resources should work in an isolated environment. One working of one virtual machine should not hamper the working of other virtual machine. So isolation is also an important issue to be handled by the virtual machine monitor. So these are some of the features, and apart from this, the last and most important feature is the emulation, which is a virtual environment and that allows the different guest applications to run on the top of the host physical machines. So this emulator is actually the hypervisor, and there lies an underlying virtual environment, which is actually a software program and that provides the control towards all the hardware resources, such that the hardware resources are managed properly, maintaining the features like security, sharing, isolation, and so that the applications are running smoothly onto the multiple operating systems. Now, there are different advantages that because we are using the single hardware physical resources available, so this reduces the cost. Apart from this, if they are properly managed, then efficiency and the performance of the system is really improved. Apart from this, better availability of the resources is there. Management is quite easy, and because the at single point the hardware is being managed, the single point administration is available. So there are different type of virtualization. In the beginning I had discussed. At this point we will be discussing about the machine level or server level virtualization. The server level virtualization is actually a technique that divides the physical server into number of small virtual server, such that each virtual server is working as an independent virtual server and it runs its own operating systems. So these virtual servers are actually the virtual machines, and the process of creation of such virtual machines is actually achieved by the concept hypervisors, which are already discussed, that we are having multiple examples. Zen server is there, Red Hat virtual machine is there, Citrix Zen server, Hyper-V is there, VMware is there. So actually each virtual machine is running in isolation on some host physical machine, and they are running in an isolation such that they are not aware of that other virtual machines are also using those host machines. So this is an important part. Apart from this, so far as virtual this machine level or server level virtualization is concerned, we are having different types of server level virtualization, and these are hypervisor, para virtualization, full virtualization, hardware assisted virtualization, kernel level virtualization, operating system or system level virtualization. So at present we will be discussing about the hypervisor. We had already discussed that hypervisor is nothing but an emulator or is a software which is actually is capable to create the number of virtual machines. So it is also known as a virtual machine monitor, and it is actually an emulator is simply software that provides a virtualization layer to which efficiently coordinates and among the hardware resources so that they run independently and they are being shared with the multiple virtual machines. So this hypervisor actually ensures that each virtual machine has its own address space, and execution of one virtual machine does not hamper the working of another virtual machine. So we are having different types of hypervisor. These are classified into two categories, that is type 1 hypervisor, which is a bare metal approach of hypervisors, and type 2 hypervisors, that is the hosted approach of hypervisors. Now just look at the diagrams. There are the figures available into this slide. So far as type 1 hypervisors are concerned, the type 1 hypervisors are directly interacting with the physical hardware. Likewise, in the firmwares, they are directly working onto the hardware. And onto the type 1 hypervisors, we are having the different operating system. RTOS is there, Linux, Windows, Unix, and on different operating systems, different applications are running. But so far as type 2 hypervisor, that is the hosted approach of the hypervisors is concerned, onto the physical hardware, we are having an host operating system. Mind it, in the type 1 hypervisor, there is no host operating system in between the physical hardware and the type 1 hypervisor. So there is a dedicated host operating system which is running onto the hardware. Thereafter, we are having the type 2 hypervisor, that is the hosted approach of hypervisors, and above that type 2 hypervisor, we are having multiple operating system above which multiple applications are running. So type 2 hypervisors is again more or less is a separate software which is utilizing the operating system to manage and maintain the different resources in the physical manner. But the type 1 hypervisor is say like it is a firmware. It is an embedded software which interacts directly with the hardware resources, and onto the type 1 hypervisors, different operating system are being can be installed, and above which different applications are running. Now, as per the comparison of the type 1 hypervisor and type 2 hypervisor, both hypervisors are actually enabling the virtualization, but the approach is different. So far as type 1 hypervisor is concerned, type 1 hypervisor is much more faster because this hypervisor is directly interacting with the hardware. That's why type 1 hypervisor is termed as the bare metal hypervisor, and this type of hypervisor directly run onto the underlying physical resources. Now, that means directly it can manage the physical resources, the processor, the storage, the networking. So that's why these hypervisors are comparatively fast. So for running this kind of hypervisor, operating system is not required, and it itself acts as a host operating system. But in type 2 hypervisors, separate host operating system is required. So these kind of hypervisors are most commonly used as a virtual server scenarios. Apart from this, the type 1 hypervisors may also be embedded into the firmware around the same layer as the motherboard. Basic BIOS is there, the basic input output systems are there. You might be understanding that what I mean by type 1 hypervisors, and this helps the host operating system to access and use the virtualization softwares. Whereas as it is discussed in the type 2 hypervisors, we need to have an operating system which directly that is the host operating system which directly interacts with the hardware, and the type 2 hypervisor runs over the host operating system, and above that type 2 hypervisors we can work with the multiple operating system above which the many applications are running. So there is an interface in type 2 hypervisor. That means there is a existence of the host operating system which act as an interface in between type 2 hypervisor and your hardware sources. So comparatively, so far as the performance is concerned, the type 2 hypervisors are slow, but the management is quite easy because we are having a dedicated operating system which is working in between the type 2 hypervisor and the physical hardware. So there are some pros and cons, there are some advantages and disadvantages of type 1 hypervisors. That the pros are that these hypervisors are highly effective as they can directly communicate with the physical hardware and also raise the level of security. So far as the cons are concerned, the administration is different, because to administrate different VMs and manage the host hardware, a type 1 hypervisor frequently requires a separate administration system. The examples are Hyper-V hypervisor, Citrix Xen Server, ESXi hypervisor, vSphere. These are some of the type 1 hypervisors. Now, so far as type 2 hypervisors, we had already discussed that host operating system relies, and it is not compatible, because why they need a host operating system, because type 2 hypervisors are not directly compatible with the hardware they are running on. So they need to separate operating system, and that's why we need a host operating system which works in between type 2 hypervisor and the physical resources. So they are best suited for the endpoint devices, likewise your personal computers, or that run an alternative operating system as a guest operating system. And actually they frequently provide a different toolkit that enhances the connection between the guest and host operating system. So again, there are some pros and cons about these type 2 hypervisors. The type 2 hypervisors allows rapid and easy access to the guest operating system, because we are having a host operating system which is running in between the hypervisor and the hardware sources. But there are performance overhead, because they always need a host operating system. Without host operating system, they cannot work directly with the hardware resources. So because of the existence of the host operating system in between the type 2 hypervisor and the physical resources, there are some administrative issues, but the resource management is quite effective. There are some examples, likewise VMware Workstation, Oracle VM, Windows Virtual PC, parallel desktops. These are some of the examples of the type 2 hypervisors. Thank you very much. I think in this session you learned about that what is virtualization. Apart from this, what is hypervisor, what is the role of hypervisor in providing and managing resources to the number of applications. Apart from this, you understood what is the difference in between the type 1 hypervisors and type 2 hypervisors. We also discussed about the server level virtualization. We will be discussing about different virtualization in our subsequent sessions. Thank you very much.